Now that we know how the grid and snaps work, let's have a look at pivots and how we can use those to transform our objects. Then at the end of this chapter, we'll take a quick look at using custom grids and the auto grid feature. We've got a huge amount of stuff to cover in this chapter, so the pace is going to be pretty quick. So I hope you can keep up with me, but I'm going to try and explain everything as clearly as I can. We're going to start off by looking at pivot points. The easiest way to think of a pivot point is as being a graphical representation of the local transform of an object. It's basically the 0, 0, 0 point of its transform space. You can see it's got an x-axis, y-axis, and a z-axis. And as we've looked at before, transforms are carried out along and using those axes. So this particular teapot has a pivot point here. That's the center of its own local transform space. If I create another object, if I create a box over here, you can see that as I'm drawing it, you can see this pivot object here. That's the pivot object for this box. And as I draw it, there you go. There's the pivot point for that object. If I rotate that object in local space, you can see that the object center is exactly where this little pivot object is. And as I rotate, it's going to be rotating around that point. That's why we call it the pivot point, because it's the point around which the object rotates. We could have also called it, the transform center or the scale center or any other name really. But in 3D graphics, the center of an object where its transform is zeroed is known as its pivot point. It's important to also realize that the geometry of an object and its pivot point, its transform space, they're two completely separate different things. In Max, that relationship is really hidden under the bonnet. You don't really see the fact that the geometry of the object is basically one distinct object and the transform is another object. That may not really make much sense to you, what I'm talking about, so I'll explain it a little bit further. When you move an object, or when you rotate it, or when you scale it, what you're actually doing is you're modifying the transform space of that object. So if I get this teapot and I move it, I'm moving its pivot point in relation to the world. And if I rotate it, I'm rotating the pivot point in relation to the world as an offset. What's also happening is the transform that I'm applying to this transform space is being inherited by the geometry of this teapot. Every single vertex and every single edge inside the geometry of this teapot is inheriting the transform that's being carried out to the pivot point of the teapot. That's why it appears to rotate. It is rotating because it's actually inheriting the transform from the pivot point. But you're not actually rotating the vertex. What you're actually doing is you're rotating the transform, and then the vertex inherits that. Now, at this point, you may be saying to yourself, what kind of crazy voodoo is Chris spouting here? What difference does it make if you're actually transforming an object via its transform or the geometry? I mean, it's the same thing, isn't it? Well, actually, it's not, and it does make a very big difference, so that's why I'm making such a big point of this. If you use another piece of software such as Maya, in Maya, this relationship is actually made very clear. In Maya, when you select an object, there's a panel where you have different tabs which actually show different aspects of the object, different nodes. And the first node for all objects is the transform node, and that doesn't actually say transform, but it actually is the name of the object, but that's actually what it is. And the second node is called shape, and that's actually the geometry of the object. So the geometry inherits the transforms from the transform node, and it's exactly the relationship that I'm talking about here. It does make a big difference, and I can actually illustrate that in 3ds Max that the two things really are separate by showing you how you can actually move the pivot point separately to the geometry of this object that we see here, the teapot, or you can actually move the geometry and leave the pivot point in place. So you can see that the pivot point and the geometry, they're not the same thing. They're not linked. They're not inextricably linked. They're just basically, there's a relationship going on there, and the geometry is the one which is actually inheriting the transform from the transform space that it's using. Let me show you first how you can change the pivot point. We need to go up here to the hierarchy panel and choose the pivot button, and we need to go in and affect the pivot only. This puts us into a special mode where now we can actually see the pivot point of this object. And seeing is not really the important thing. The important thing is that we can modify it. We can grab the pivot and we can move it over here. And we can rotate it if we want to. So now what I've done is I've actually rotated the transform and moved the transform of this object, and I've left the geometry in place. So if you can imagine, what we've done is temporarily is we've actually broken the link between the geometry here and the transform, and that allows us to actually offset the transform in space and also to rotate it, and the geometry doesn't actually inherit that transform and therefore it stays in place. And we can actually do the opposite here. If we look at the second button down, you can see it says affect object only. If I click on that and we go to transform, you can see, I'll actually use local space for this. You can see it appears to be exactly the same option. And that's because we've offset the pivot point in space. So what we're going to do now is we're going to move the geometry of this object, but the pivot is not actually going to go anywhere. So if I move here, you can see the pivot point is actually going to be left where it is already. The transform is going to remain the same, but the actual geometry is going to be offset in space. And we can do the same with rotation. So that shows you that the pivot point, the transform, the local transform of the object, and the geometry of the object are not the same thing. Effectively, the geometry is a child of the transform, and that means that when we're out of these special modes and we do a translation, the geometry also inherits that translation. And that makes a massive difference when you're doing certain things in modeling and certain things in rigging. And I'll give you a quick demonstration of that in a second. But before we finish off looking at this aspect of the transform, I just want to show you a few more of the features of this particular tool here. I'll turn on Affect Pivot Only, and now what I can do is I can actually adjust the pivot point by using these buttons here. What this one will do is center it to the geometric center of this teapot. So there we go, it's now in the center of the teapot. That may not actually look like the center to you, but if you take all of the vertices and you work out their positions in space, and then you did an average, you'd find that the point is exactly there in space. That's the actual positional center of all of this geometry. The other option you have is you can align the pivot point to the geometric alignment. So as you can see, we've actually given it back its original relationship now, although obviously you can see the position is still wrong. We'd actually have to move it manually to here to roughly put it back where it was before. And you can see the last option we have here is to align the pivot point to the world. So we've actually aligned it to world space there. We don't actually have the option to center it to the world, but there you go, as you can see. And if we click on Affect Object Only, we have the same kind of features, but with the relationship flipped. What we can actually do now is we can center the geometry to the pivot. There you go. And we can align to the pivot, the geometry to the pivot. We'll just center it again. And we can also align the geometry to the world. So if I just rotate this again, we can align the geometry to the world. Not actually centering it though. So we could align to the world, then center the pivot, make sure those two are the same. So there you go. It's very easy to modify the pivot point of an object in 3ds Max. And the other thing to bear in mind is snaps can also be used, very much recommended also to use snaps to snap the pivot point to a vertex or to the grid point or to the pivot point of another object. So you can do a number of things with pivot points in that way. Okay, so you should understand now that the transform of an object is distinct to the geometry. And what difference does it make? Well, I'll give you a very quick demonstration of what difference it actually does make. In 3ds Max and in most other software, you can create what are called hierarchies, and that's easy enough thought of as being like a family. So we'll copy this object 6 times there just by holding down Shift and dragging. What I can do now is I can actually make all of these boxes children of this teapot. So I can just click on this button here, select and link. We'll just make them children of it. Now, when I rotate this teapot, you can see all of these cubes get rotated also. What you're actually effectively doing when you do that is you're saying to these objects, don't use your own transforms anymore when this object is selected. When your parent is selected, don't use your own transforms anymore. Instead, use your parent's transform. If we click on the object, you can see that we can still rotate it around its own local space. But if we click on its parent, although you don't realize it, these objects are now using the parent's translation space. When we rotate this object, you can see that all the cubes get rotated too. When I translate the object, all the cubes get translated too. And when I scale the teapot, or rather when I scale its transform, because that's what I'm actually doing, then you can see that not only does the teapot's geometry get scaled along with a transform, but also all of the cubes do also. And you can see they're getting very, very squashed. That's an example of what happens when you scale the transform. And it makes a big difference when you have a hierarchy. If I take all of these cubes, and if I break the link, so now they're not children anymore, so I can actually rotate the teapot, and you can see they're all individuals again. But what I could do is I could scale this teapot, and this is a really good example of why scaling is so dangerous when you scale transforms with regards to rigging, because what I'm showing you here is kind of related to rigging. I can scale this teapot and really, really squash it down on the x-axis. I can then get all of these cubes. And actually, let me just show you something here. Have a look at the scale of this cube. It's 100, 100, 100. It's not been scaled. Look at this teapot. Do the same thing. You can see it's 14 point whatever. 100, 100. It has been scaled. So then when I get all these cubes and I link them, I make them children of this teapot, what you might expect to happen is for them to immediately inherit the transform of this object and therefore become squashed, to become scaled. Well, let's try it. You can see that that doesn't actually happen. If I select this object and I rotate it, you can see that it's all pretty much working fine. But now if I go in and I change if I look at the scales, for instance, of these objects again, you can see that they're actually scaled. You can see that on X it's got a scale of 685, on Y it's 9.9999, sorry, 99.9999. So you can see this cube, which looks unscaled, didn't change its shape or anything, actually does have a scale applied to it. And the reason for that is that because it's a child of this teapot and this teapot is scaled, if we look at this, you can see the scaling that we've got going on here. 3ds Max has to apply a counter scale to this cube to keep it the same dimensions as it was when it was unlinked. So the problem with that is that if we then reset the scale on this object, if I go in here, right click, and reset its X scale to 100%, you can see what the problem is. The scale that you've applied to all of these objects transparently when you actually link them to this thing, when you actually reset the scale of this teapot, all of these cubes then have that scale applied and they then become stretched. So now you've got all these deformed cubes here. And that is one of the main problems with scaling. And you can really make a mess of a hierarchy if you have multiple objects which are transformed and scaled. And then you link objects together, then you need to unscale it. You unscale them, they become all distorted. And, you can have this can be really, really nested. You can have multiple levels of hierarchy, and at each level there could be different scales going on. When you start manipulating those, all those scales get inherited along the hierarchy, and you can just end up with a total mess. So that's why it's bad to do scaling to the transform. You might be saying to yourself, well, how am I supposed to scale an object? Well, the easiest way to do that is instead of scaling the transform, you need to scale the geometry instead. You can do that in a number of ways, but I'm just going to show you a very quick way here. I'm just going to get rid of this teapot because it's on a funny angle. I'm going to create a new one. And I'm going to create a few more cubes again. Let's create some boxes. There we are. Create a few. Just move them up here a little bit. And what I'm going to do is I'm going to scale this object, and then I'm going to link these to it, and we're going to see if we have the same problem as before. So instead of scaling the transform, I'm going to actually change the geometry. I'm going to scale the geometry instead. And to do that, I'm going to use a modifier, and we're going to come to modifiers later in this DVD. But for now, let's just skip ahead. I'm going to use an edit mesh modifier, and I'm going to go in, and I can use any of these sub-objects. I'll use polygons for now. And I'm going to select all of the polygons in this teapot, and you can see I'm going to use, it's using view up here, and it's also using use pivot point center. It's actually using the pivot point center of each polygon. So that's really something we don't really want to do. So what we're going to do is we're going to say parent, and then we're just going to use the geometric center. Or the other option is to use, probably this makes the most sense. So this gives us basically the transform space of this object for us to work in. Actually, we needed to do that while we're in scale mode. So let's just do the same thing again. There we are. What I'm going to do is, again, I'm going to scale it on the x-axis. I'm going to squash it right up. There we are. So we've actually squashed the object just like we did before when we modified its transform. I'm going to come out of this mode, and I'm going to get all of these cubes. I'm going to make them children of this teapot. And I'm going to come in, look at the scale of these cubes. And as you can see, they've got a perfectly unscaled transform. They're all at 100, 100, 100. And if I go over here and I look at the teapot, we've got exactly the same thing. We've got a scale of 100, 100, 100. So the fantastic thing about this hierarchy now is that we've scaled this geometry. We've made these cubes children of this teapot. We've generated this hierarchy, but nothing is actually scaled. The transforms are still at 100%, 100%, 100% in X, Y, and Z. Now, there is actually a downside to what I've just done. And what it is that it's actually quite difficult to get the teapot geometry back to what it was before I actually scaled it. There's no real record of the scale value that I used. So what I'd have to do is I just have to grab the x-axis and pull it out until I thought it was roughly back to the same dimensions as it was when I started. But by using a modifier, and this is something that we'll come to later, I've actually performed this modification in an isolated way, and I can actually get rid of it by getting the modifier and just deleting it there. And that puts the teapot back to the original scale. So you can see that by modifying the geometry, by scaling the geometry, we got a much better result when it comes to creating hierarchies. And that's a real issue when you're talking about doing any kind of rigging. With modeling, it's not such a big issue, but, you know, what goes for rigging also kind of applies to modeling as well. So it's a good idea generally not to scale the transform of an object, but rather to scale the geometry. Something you may have noticed me using was up here, this little flyout here, and these are different types of pivot, and these work in conjunction with reference coordinate systems. So we know what the reference coordinate systems are, so let me explain what the pivot types are. Let me just create a bunch of objects, and then we'll be able to see more clearly what's going on here. Let's create a bunch of teapots. I'll just offset them in 3D space a bit, so some are higher than others. There you go. And what I'm going to do now is I'm going to transform them. I'm going to use these different pivot types to transform them in different ways. So first of all, I want to transform them all at the same time. I want them to transform around a common geometric center. So for that, I'm just going to select all of the teapots. I'm going to go into rotation mode by pressing E. And you can see I've got basically a rotation gizmo around each object. That's not actually what I want. So let me just choose the right option here. I'm going to use world space as the coordinate system. And you can see the option that I have here now, which is called use selection center. What that does is it creates a pivot point on the fly based on the selection that you've actually currently got. So you can see at the moment the pivot point is here. I just selected these teapots. The pivot point will be here. And you can see as you change your geometric selection, the pivot point changes. It's always going to be in the geometric center of all of the objects. So now if I select all of the teapots and rotate, you can see they're all rotating around that pivot point, which is kind of cool. You know, in certain circumstances, that's exactly what you want. Another circumstance is you want them all to rotate around their own pivot points. So we can choose this option here for that, which is called use pivot point center. Kind of makes sense, doesn't it? Now, this is using world space, so you can see that all the gizmos are aligned to the world. But when I rotate, you can see all of the teapots are rotating around their own local transform pivot, as you can see. If I rotate some of them individually, just to give them a slightly off alignment, and select them all again, you can see that the gizmos are still based on world space, and they're all rotating around world space. Well, I can actually go up here and I can change this to, let me just undo that. Just change that to local space. And now you can see that the gizmos here are actually aligned to the local space of each object. Now, I'm just using minus here to actually make the gizmos a little bit smaller. Now, in most cases, these teapots are actually still aligned to the world. So therefore, you know, by using local here, you don't really see any difference. But of course, these two teapots have been rotated. But if I grab the Z ring and rotate it along there, you can see this object is moving along its own Z axis, and all these other teapots are rotating along their own Z axes as well. So, you know, if I just get this one, just rotate it around a bit and select again, I'm just going to grab the Y axis, and you can see they're all rotating around their local Y axes. So by using a combination of reference coordinate systems and pivot types, you can choose exactly what coordinate system you want to work in and what pivot point you want to rotate around. So as you can see, you can use the pivot points of each object, you can use the geometric center of all the objects, and the last option, which is here, doesn't really make any sense in local space. So what I'll have to do is change to world space, and now you'll see that the pivot point of all the objects is actually the center of the world, because it's using the center of the coordinate system that I've currently got selected. We're using world, center of the world is here, all rotations take place around here. I hope that makes sense. If I was to pick this teapot as the coordinate space, the center of the coordinate space would be the pivot point of the teapot under here. So let me just show you that. I'll just pick it, pick that teapot. That's now the coordinate space. I'll just select all of the teapots, and now you can see they're all going to rotate around that teapot because they're using its center, its pivot point, because it's the current reference coordinate system. So there you are. You've got those three different options there. You can use the local centers, the geometric center, or the transform reference coordinate system center. You've got those three different options. When you're working with local pivots, that doesn't really make that much sense when you're using world space. And also when you're using coordinate system centers, that doesn't make any sense when you're using local. So, you know, if you choose this option here and you go to local, that doesn't really make any sense because the pivot of each object's, the center of each pivot is actually the center of each local coordinate space. So effectively, you're basically using this option. There's no difference between the two. And if we changed over to world space, this option makes sense because we're in world space, but we want to rotate around the center of each object. And that works perfectly fine. But then, you know, if we were to go to here and we were to use, if we were to go to local space and then we choose this option, it really, you know, doesn't make any difference really because it's actually in the same coordinate space. So the two are kind of mutually exclusive. Let's move onwards. I'm going to just look at two last features before we finish off on this chapter, and I'm going to do it pretty quick because we've been in here for quite a long time. I'm going to show you AutoGrid and Custom Grid. I'm just going to create a teapot here. And the first of those two features is AutoGrid, and it's a really easy system to use. You just turn it on here, and you can see it's available for quite a few different types of object. Well, it's available for helpers, I believe, grid. There we are. So you've got AutoGrid turned on. Choose OmniLights. You've got AutoGrid as well. So you can use it on multiple types of geometry. What it does is it very quickly creates a kind of on-the-fly grid just like the home grid that you can see here, and aligns it to the face that you currently have your mouse pointer held over. And that kind of allows you to create on-the-fly grids. That's what it is, AutoGrid. I'll just show you how it works. If I zoom in here on the teapot, I'll just put on shaded mode. Actually, let's change the color of this teapot. It doesn't really work very well in shaded mode, does it? Let's just use some AutoCAD colors, and I'll just choose this bright blue. Turn on wireframe, and if I click on teapot, we've got AutoGrid turned on, and you can see that as I move around, you can see when the pivot of this potential teapot, which you haven't actually created yet, when it hits a polygon, you can see the AutoGrid feature snaps that pivot point and actually aligns it to the face that it's currently over. You can see the Z-axis is pointing out of the face. You can see it's actually pointing along this axis here. So as we move it around, you can see it's changing orientation. And we can just create a T-point at any point. Just click, drag. You can see it actually creates this grid here. And we can just choose what size we want and leave go. Click, drag, click, drag. So you can just create teapots, which actually sit perfectly on the surface of this object here. And it's doing that just by very quickly creating these little grids, which you can see here, aligned to the face. And it's as simple as that. That's what AutoGrid does. And, you can create an object with AutoGrid, create another object on that object, another object on that object, another object on that object, and so on and so forth. Pretty much one of the first things people always do with the AutoGrid feature is create these little stacks of teapots or cubes or whatever. It's just good fun, really. And that's it. That's the AutoGrid feature. It's great for set dressing, very quickly building, say, rivets on a complex surface. And the great thing about it is that you don't really have to do any preparation. You just turn on AutoGrid, and then you just draw on the surface, and you can very quickly place objects. That's great, but what about if we wanted a slightly longer lasting grid, one that we could use to place multiple objects? Well, that's also catered for in 3ds Max. It's a helper object, which you can see here. If we click on helpers, we go down to grid. We'll just create some grids. Just turn off AutoGrid for a second while I do this. It's going to create one here, create another one here, and I'll just rotate that manually to some kind of weird orientation. And the great thing about grids is you can also use AutoGrid to place them. So I'm just going to turn on AutoGrid. I'll place one here on the side of the teapot. Just make sure it's big enough so we can easily select it. And let's just choose another one here. There we go. And they're very easy to activate. What you do is you just click on one, right click. You've got the option here to activate the home grid or activate the currently selected grid, which is this one. Turn it on. And it's now basically a construction plane. And what I can do now is I can go and create, say, teapots. And you can see that we're going to be creating teapots. Let's just turn off AutoGrid. So you can actually just create teapots, and they're going to be created on that plane. It's now become the new, as it were, home grid. Pretty cool feature, eh? You can see we actually created all those teapots there. And you can actually get out of using that grid at any time just by right-clicking on the viewport. Sorry, let's just choose this object here and activate the home grid again. It's actually kind of hard to come out of that because for some reason it wasn't visible for a second. We can do the same thing with this grid here. We can just right-click on it and activate it. And again, it's become hard to see for some reason. Let me just go to wireframe mode. Nope, still hard to see. Don't really understand why that's happening, but anyway. Now that transform is actually in that plane. So now we can create objects on that plane, as you can see. And this plane goes off to infinity in all directions. So there you go. Pretty cool. And as I said, all you need to do is just, select that plane and just click on activate home grid, and you'll go back to using the home grid as your reference system, your construction plane for that particular point in time. So, actually, before I go on, I've just realized why the custom grids weren't displaying there when they were activated. It's actually not. I thought it was a bug there for a second, but it's actually not that. What it is that when you activate one of the custom grids, it changes its display to show the current grid setting that you have on that particular helper, So you can see this for yourself. If you click on one of those custom grid objects, if you make one in your own scene, click on it, you'll see there's a grid setting. And the problem was that on those particular objects, I defined the size of the grid, and the grid setting was so large that it couldn't actually display any of those grid cells even once, which means that when you activated the grid, basically it disappeared. If you were to get one of those grids again and put the grid size down and then activate them, it would actually be able to display some of those grid cells, so it would actually not disappear when you activated it. So I thought I'd just clear that up before we continue. So two little, great systems there. You've got AutoGrid and you've got custom grids. You can use them both together interchangeably, really, and they can be used for different circumstances. Custom grids are great for circumstances where, for instance, you might be building the side of an aircraft carrier and you want to place pivots along a plane, and it's a nice flat surface. You just create a custom grid that actually is aligned to that plane, activate it, and then from then on you can just build all your objects on the side of the ship very easily, and they'll always be aligned to the side of the ship. The other option is you can turn on AutoGrid, and if you want to create spheres, you can actually move those and place them directly onto the side of the object as well. And that's really great when you've got organic objects with very complex curved surfaces. AutoGrid will just, place it on the surface wherever, and it'll be perfectly aligned to the surface. So they're both really cool features. So there you go. That's it for this chapter. And in the last 3 chapters, I focused on features in 3ds Max that allow us to work with our 3D models, how we can move them around, the various transform spaces that we can work in, picking custom transform systems, and so on. We also looked at the home grid, creating and using our own custom grids, which we've just looked at, and also using the auto grid. And we learned that we could not only create objects on these grids, but that we could also use the snap system to locate them on the grids in a very accurate manner to make our modeling more accurate. We could place, we could snap to grid intersections or the edges of the grid, whatever. And we could also use other objects as well. We weren't just limited to using the grids, but we could snap to vertices and faces and so on and so forth. And we also learned that what the pivot point is and how we can choose various types of pivots to work around reference coordinate systems, so on and so forth. So I think now you should have a pretty good idea of how to move objects in 3D space, what transforms are, what pivots are, what grids are, all of that kind of stuff. But we've not actually done that much deformation of an object. We haven't really done any sort of real modeling. Now, in the next few chapters, we're going to make a move on from these key concepts, and we're actually going to move into doing some very basic modeling. I'm not really talking about creating elaborate models here, but I'm going to take some primitives and I'm going to change the geometry in some way. And in my book, that I would class as modeling. I'm not going to do anything complex, but we are going to change the geometry. We are effectively going to model the objects. We're going to start with some simple changes by using things called modifiers, which you may be familiar with already. And we're also going to use space warps. They're both kind of related to each other. Anyway, let's make a start now by looking at modifiers.